Hello everyone, in this lecture we are going to solve a problem on the topic limit cycle behavior and deadband of the system. So the question is, an LTI system is characterized by the difference equation y of n equal to 0.87 y of n minus 1 plus x of n. Determine the limit cycle behavior and the deadband of the system when x of n is equal to 0 and y of minus 1 equal to 0.61. Assume that the product is quantized to 4 bits by rounding. Here we are rounding off with excluding sign bits. So the solution is y of n is equal to 0.87 y of n minus 1 plus x of n. Here x of n, y of minus 1 is given, and the alpha is the coefficient of y of n minus 1. So here it is 0.87. So the next step is to find the deadband. The deadband formula is 1 by 2 power minus b alpha divided by 1 minus mod alpha. Here we are multiplying the deadband with the alpha because we are given with y of minus n 1 value. So we are multiplying the deadband with alpha, and then we are substituting the values of b alpha, so we get 0.2091. So we have to convert this decimal value into binary. As we all know the conversion of decimal to binary, we have to multiply this value into 2. We get this, and if further goes on, and if we get the value as 1.6732 means we have to consider the values after point. So 0.6732 into 2. Here we are given with bit b equal to 4. So we have to do this process up to 5 values. After that we have to write it as 0.00110. Again we have to convert this decimal value into rounding off. Rounding off means we have to add this fifth bit to the fourth bit. So we will get 0.0011. Again we have to do a conversion of binary to decimal. As we all know, this is the conversion of binary to decimal. We have to multiply the first bit with 2 in 2 power minus 4, and then 1 with 2 power minus 3, and we have to add this value. So this is the final decimal value, and here it is the deadband value. And then we have to this is the direct form of calculating deadband. We have to do quantization for each n values. So consider n equal to 0. If we substitute n equal to 0 here, y of minus 1, we have value for y of minus 1 as 0.61, and then multiplying the value of y of n minus 1 into alpha, we will get 0.5307. It is in decimal value. We have to do the conversion of decimal value into binary. Here I have done this. So in this format you have to convert the decimal value into binary value. As I already said, if you get 1.0.0614, this kind of value means you have to consider the values after the points. So 0.0614 into 2. We have to do this for 5 steps, and then we have to write it as 0.10000, and then we have to do rounding off. Rounding off means adding this fifth bit into the fourth bit, so we'll get 0.100. Again we are converting this binary value into decimal, we will get 0.5. Then this is the final equation, y of n equal to quantization of alpha y of n minus 1 plus x of n. We have the value for quantization of alpha y of n minus 1 as 0.5. Here for all n values, the x of n is 0. So here it is 0. So we will get y of 0 equal to 0.5. Again, we'll go for n is equal to 1. When n is equal to 1, y of n minus 1 is y of 0. We have y of 0 as 0.5. We are considering here it as 0.5, and then multiplying it with alpha, we'll get 0.4350. Again it is in decimal. We have to convert this decimal value into binary. We have to do this step for five steps, and then we have to round off. Rounding off means adding this 1 to 0, you will get 0.0111. Converting this binary into decimal, we would get 0.4375. This is the quantization of alpha into y of n minus 1. This final step we have to substitute that. I have already told that n for all n values x of n is 0. So here also it is 0. So y of 1 equal to 0.4375. Again we are considering it for n is equal to 2. We substitute in y of n minus 1 means we'll get y of 1. We have the value here. So consider it here, and then multiplying it with 0.87 we'll get a decimal value. Again convert this decimal value into binary value. Again do the rounding off process. After rounding off you will get like this. Convert this binary to decimal, you would get 0.375. Again substitute here, you will get y of 2 as 0.375. Again for a consider n is equal to 3. N is equal to 3 means y of 2. In the previous step we have y of 2 equal to 0.375. So here also 0.375. Multiplying it with the value of alpha, we will get decimal value and convert it to binary, and then do the rounding off process. After rounding off, convert this binary to decimal and substitute in the final formula y of 3 equal to 0.3125 will get. And then we have to do for n is equal to 4, n is equal to 5, n is equal to 6. Up to how much steps we have to do is up until then we will get the value same as the deadband value, and this has to the last two steps has the same value as deadband value. If we get like this means that is the final process of solving this problem. So here also while considering n is equal to 5, we are doing the same process. Y of 4 equal to 0.25 as in the previous step. Multiplying it with 0.87, we will get decimal value. Convert this to binary, and then rounding off, and then to binary to decimal. If you substitute means y of 5 on the 0.1875. This is the value of deadband. We have to solve for another n value, that is 6. Here if you solve means y of 5 equals 0.1875. Again multiplying with 0.87, you will get a decimal value. Convert this into binary and then do rounding off. After rounding off the binary value, convert this into decimal. If you substitute in this final formula, again you would get the same answer as previous. These two are same as deadband, so the problem is solved. This is how you have to solve the limit cycle behavior and the deadband sum of the difference equation. Thank you.